Navya, hear me?
No, sir. Yes, sir.
Can you hear me now?
Yes, very clear.
Okay, okay. Okay, so it's 11:02 now. So we have all the very good response to this today's webinar. So we almost have 550 registrations. So we expect full house as we progress. So I would like to welcome to NFE's webinar. So I will just run through what we have been doing in NFE, and we are the only organization in India meant purely for electrical engineers or probably engineers, safety engineers. There is no other society in India for electrical society, though there are few for manufacturing. So we are the only association involving professional electrical engineers. We are in all these safety professionals are member. I'm so happy to say that we are one of the fastest growing society in India. In less than 1.5 years, we have crossed over 1,500 members. And what greatness about this NFA is every month we are connecting with over 2,000 to 3,000 people through various programs like webinars. We have physical seminar. Seminar, when it comes, we have done over 25 seminars across the country, length and breadth of this country, and over 300 webinars since last 2.5 years. And we continue to create awareness on electrical safety, and this is our mission to make every electrical installation free of accident. If you look, when you read the newspaper every day, you find there are some electrocutions, lightning, people dying due to lightning, earthing issues. So we are here today to make sure that we strive and achieve through this association. And our mission is strive to achieve our vision through getting accredited for product and personal certification, which I'm sure Mr. Gopakumar will also talk about it. What is a personal certification? Which shall focus on electrical safety by design, manufacturing, installation, and maintenance of electrical product and installation by competent, qualified manpower using quality resources, including product, process, and procedures. So what we do, as you've seen today, we create awareness on electrical safety. So it's less than a cost of one dinner with your friend or a lunch with a friend. It's just 1,000 rupees a member. So those who are not member, we request or urge you to become a member, and you participate in all these knowledge sharing informations. We have a very active group in WhatsApp and other social media group where your doubt, questions, and your articles can be shared with all these group member. So as I said, we are over 1,500 members. So we invite corporates who are into manufacturing or product solution also to join. We also have a MSME. It's a 2,500 is the annual fee. So far we have done, if you've seen from February, we talked about power quality and harmonic distortion. We spoke about harmonic distortion, power quality panel discussion. We had a very eminent leaders joining for this discussion, and power quality again and mitigation. So electrical safety in PV installations. We had an international speaker from Poland who spoke about it. Then we had our Polycab, our corporate member, talking about green wire, sustainable building. We also spoke about system earthing and fall protection, prosumer installations. And recently we spoke of very good, we have over 1,000 participation for electrical fire in the hospital. Why is it happening? So wonderful program we had. The last we had functional earthing of ICT, information and communication technology, very successfully completed, very engaging webinar. And just 2 days back, 26 June, We with CA launched an awareness program, Safety Start from School. It's a wonderful program in Delhi. We, with the support of BAS, we had a full day seminar. Very soon we had the chairman of CA inaugurating, and he was the chief guest of this. Very good program, and we continue to do these kind of seminar across the country. And today, very important subject, electrical safety of lift as per IS 179001. We have speaker Nitin Kadam is going to talk about it, and we have opening remarks by Gopal Kumar is going to address us. And today webinar is on electrical safety lift, focusing on the guidelines laid out in IS 179001. Safety in lift is not just a regulatory requirement, but a critical aspect of ensuring a well-being of everyone who uses operates the lift daily. So throughout this session, we encourage our participant to put your question as we explore how these standards can be effectively applied in real-world scenario. We trust this knowledge webinar will make you confident in your understanding of electrical safety in lifts and empower and implement these standards effectively. So while our speaker talking about it, there's a Q&A box down. So use only the Q&A box. Do not put your question in chat box. When you put it on chat box, that will not go on recording. So I encourage everyone to put your questions only in Q&A box. So thank you once again. We have over 200 participants now. So thank you once again for joining us. So let's start with introducing our speaker today. That is Nitin Kadam, General Manager, Product Safety from Schindler, India. He's a Bachelor of Electrical Engineer and Masters in Marketing Management from Mumbai University. He associated with elevator and escalator industry since 1986. Sorry. Worked in various functions of escalator and elevator industry from field operation to R&D. At present, he's a GM of Product Safety of Schindler, and he's also represent Schindler in the codes and standards in the BAS committee. He also represents BAS in ISO TC 178 WGL 5 since 2020, which is responsible for drafting ISO standard for elevator and escalator. He representing WG5 in ad hoc group dedicated for revision of ISO 8103 and ISO TS 8103 under the lead of WG2. We have our president of NFE, National Federation of Engineers for Electrical Safety, Mr. Gopal Kumar, well-known face. I don't need more introduction about him. He is a man who never sleeps, traveling length and breadth across the country. He is very passionate to ensure that Bharat becomes electrically safe country. I would now welcome Mr. Gopal Kumar to begin with his opening remarks.
Thank you very much, Mr. Dominic, for the introduction, and welcome all participants for this nice program. This is in fact, our second program on lift and elevators. I'm sure most of you must have participated in the earlier program. Now I am trying to display the standard which we are going to talk today, which is IS 17900. Please note that this is a new standard, IS 17900. Basically, the standard has been, I'm sure you are able to see the standard on the screen. Part 1, 2022. This standard supersedes the earlier standards with respect to lifts and elevators, IS 14665 Part 1 and Part 2, Section 1, 2, and most of the other standards are. Of course, the validity of the old standards, it will be still valid for some more time, but after some time, this 17900 is going to, this is going to be the new standard. It talks about lift for transport of persons and goods Today we are going to focus, of course, lift it contains electrical, mechanical, hydraulic, and several parts. The safety of each of these parts is important. But today we are mostly going to discuss about the protective measure, electrical safety measure. So electrical safety measure basically is explained in the clause 5 of this particular standard, and mostly the challenge which we are facing is on this particular clause, for example, 5.10.9. So the IS 17900 says you should follow the requirements of 4.2.11.3.1 of IS 732. Basically, this IS is from ISO standard, ISO 8100. So in the ISO standard, the clause, respective clause of IEC 60364 is mentioned. So basically, this clause of IS 732. I also have on my screen IS 732. I am showing you the clause, which is the protective earthing. So this particular clause explains about, for example, it talks about how the protective, earthing for safety has to be carried out in a lift. Basically, it talks about from the clauses 4.2.11.4 to 11.6. This talks about what we should do in a T system, what we should do in a TT system, what we should do in a IT system. So basically, we are talking about these two standards, and Mr. Nitin is actively participating in various standards, and we have the best speaker for this particular subject. I welcome Mr. Nitin for the presentation. Let me stop the presentation. So over to you, Mr. Nitin.
So good morning all, and Mr. Dominic and Mr. Gopakumar, thanks for the kind words. I welcome all the participants here for this session today. As Mr. Gopakumar and Dominic were saying, that this is about the IS 17900 part 1, and we'll see how this also mentions about the IS 732, gives the reference of IS 732 and the protective protections in the electrical side. I'll share my screen. Let me know if everybody can see it.
Not yet.
Not yet.
Yeah.
Is it visible now?
Yeah, now it's, yes.
Okay. So as the topic for today is the electrical safety of lifts as per IS 17900-1. And the topics that I'll cover today, I'll briefly touch upon the hierarchy of regulatory framework for India, the electrical safety framework for India, significance and evolution of the electrical safety regulations. We'll speak about the IS 17900 and IS 732, clauses for automatic disconnection, earthing and earth, the protective devices, their types, and as Mr. Gopakumar was just mentioning, the type of earthing networks, that is the TNS, TNCS, TT, IT, and so on. The earth fault loop, its impedance, the purpose of earth fault protection, protective potential bonding, automatic disconnection of power supply, and what are the devices that are applicable with respect to the network types, and how do we verify this automatic disconnection on the site is one of the important topics we will see today. I move on to the next slide. So this is the hierarchy of the regulatory framework in India. So on the top, we have the Act, which is enacted either by the Parliament or in the case of the state, it is the State Legislative Assembly. And it is followed by the regulations, which basically is about how to follow the requirements that are specified in the Act. Then we have the Code of Practice, which is a practical guide on how to comply with the legal provisions, followed by the standards, which are the specification and the procedures to ensure products and services, how they are performing. And then you have the operational document, which is a description of the organizational activities and processes. So this is how the regulatory framework in India is. May it be any act or any rule for any of the product that is launched in India. As far as electrical safety requirements are concerned, the framework is again the same, but at the top you have the Electricity Act 2003, and you have the CE regulations, safety regulations 2023, and as the standards, the code of practice, you have National Electricity Code, which is 2023, NBC 2016, IS 3043, and IS 732. Now, why do we talk about all these requirements here? There are a lot of accidents happening due to electricity in India, and it is in all walks of life. There are a lot of injuries, a lot of fires, deaths happening in the buildings like hospitals, malls, hotels, residential buildings, factories, construction sites. One of the equipment on the construction site is also the elevators. And if you see here, the data says more than 100,000 people have lost their life in the last decade, and the number has rose to 12,528 in 2022, which is equivalent to around 34 fatalities daily on an average. And here, therefore, it is very important to know, why we have to follow the regulations and why we have to comply with the rules that have been laid down for the electricity or the electrical usage. So all the stakeholders involved here have to play a major role. They're part of their role. So right from the supplier of the electricity, where they have to ensure that they provide the incoming power supply to the consumer premises, which is safe for usage. The customer in the building or the installations have to ensure that whatever is done within the installation is safe for usage, and we, as part of the electrical requirements for the elevator and the escalator, as an industry, we have to ensure that the equipment, which is elevators or the escalators, are safe for usage for the technicians who are working on the elevator, as well as for the end users who will be using the equipment day in and day out for their travel in the building. So if you see here, this is how the regulations have evolved in India. So we had the Indian Electricity Rules 1937, followed by the rules in 1956, followed by the CA regulations in 2010. And now we have the latest regulation, which is CEA Safety Regulations 2023, which was notified on 8th of June 2023. So please refer to the latest regulation. The earlier regulations have been repealed. Please do not refer to that. This is my sincere request to all of the audience here. So the regulations are mainly related up to the point of commencement of supply, and after the point of commencement of supply, according to Regulation 14, the NEC or the NBC applies. So what are the major upgradations in the elevator standards that have happened at the global level and the India level? Let us see those standards. So if you see here, at the global level, we had EN 81.1 and EN 81.2, which was revised to EN 81.20 and EN 81.50. This was completed around 6-7 years before. Now, EN 81.20 and 50 was adopted by ISO, and it was taken over as completely as the same standard, renaming it as ISO 8100-1 and 8100-2 for the elevators. Now, when we talk about the India scenario, ISO 8100-1 and -2 was adopted by BIS as IS 17900-1 and 2, that is part 1 and 2, and this was launched in December 2022. Now, IS 17900 part 1 and part 2 is going to replace IS 14665, 15785, 14671, and so on. But at the moment, this is a concurrent running code, the IS 17900-1 and 2, as well as the IS 14665 and 15785, because the BIS gives time to the elevator and the escalator industry to be prepared for the launch of the equipment or the products into the market according to the new code requirements. So as of today, by December 2024, all the companies have to be ready according to the IS 17900-1 and 2, and ensure that the products they are launching in the market from 1st of January 2025 meet the requirements laid down in 17900. So let us see how this is related with the IS 732. If you see here, the 17900 explicitly specifies the clause B, like 6.3.2 B and D, which talks about the continuity of the protective conductors according to 6232A of IS 732, which Mr. Gopakumar was also specifying. And then the part D, or the subclause D, which specifies verification of effectiveness of the measures of fault protection, protection against the indirect contact by automatic disconnection of supply according to 6236 and 6237 of IS 732. It also further states that the protective conductors, including the main and the supplementary equipotential bonding, has to be checked. And for the TN systems, the measurement of fault loop impedance has to be done. Now, further, if you go, the clause 4.2.11.1b specifies the fault protection by protective equipotential bonding and automatic disconnection of the power supply in case of faults, according to the clauses 4.2.11.3 and 4.2.11.6. We'll see what these are in detail in the subsequent slides. But let me specify here that the IS 732 is not a new code in India. It is existing for decades. IS 14665 also had a reference to IS 732 and IS 3043, but somehow this code has been overlooked, and this part of protective equipotential bonding and the automatic disconnection of power supply has been missed out big time by the elevator and escalator industry. But now IS 17900-1 explicitly specifies that you should have a protective equipotential bonding and automatic disconnection of power supply. And in the previous slide, you must have also seen fault loop impedance test has to be done. So this is the verification of the equipment on the site by doing certain tests. We'll see those in the subsequent slides. So why, like, let us also understand, because people talk interchanging the words, like earthing, earth, grounding, and so on. So what is earthing? Earthing is basically a metallic conductor, which is, connecting the exposed conductive parts of any equipment to the main earthing terminal, which is helping us to automatically disconnect the power supply in case of fault. It is also providing low impedance return path to the fault current. It also helps us to define the type of earthing network that is made available at the building premises. And it also helps us to define what kind of protective devices have to be used based on the type of earthing network that is available in the building. It also prevents shock to the human beings and also fire in case of livestock when there are earthfalls that are happening. Okay, and this metallic earth return part also defines the fault loop impedance value, and this has to be verified on the site, as I was mentioning in the previous slides. Now, when we talk about earth is generally not used as a part of return part to the fault current. It is mainly to fix the voltage on the system neutral, so that there are no shock hazards that are available onto the exposed conductive part due to indirect contact. So what are the kind of earthing networks we have? There are basically TN, TT, and IT networks which are available, and the TN system is further divided into TNS, TNCS, and TNC system. Let us see how this networks look like. Now, if you see here, in this network, you have the three phases coming to the building installation, followed by a neutral and an earth. So basically, this is a 5-wire system where you have a neutral and a protective earth conductor coming right from the secondary of the supply transformer to the building installation. Okay, so these are dedicated neutral and dedicated earth wires coming from the star point of the secondary of the transformer, which is supplying to the building installation. When we talk about the TNCS network, in this case, again for the installation, you have a 5-wire. But if you see, there is a difference here in this part where you have the PEN conductor which is a common conductor, common earth and neutral conductor, which is coming from the secondary of the transformer up to the main earthing terminal. And here it gets separated into a separate neutral and separate earth. Okay, so this is the difference. So if you say TNCS, so it is a combined neutral and earth coming up to certain point, and further it is getting separated, and therefore it is TNCS. Now, this PEN conductor is also earth at multiple locations. So in case of breakage of this PEN conductor, it is possible to limit the voltage on the neutral, so there are no shock hazards that are exhibited. Going to the next network type, it is a TNC network. If you see here, there are only 4 conductors which are coming from the power supply transformer or the distribution transformer to the building installation. You have the 3 phases, and you have a common PEN conductor, that is a common protective earth and common neutral, which is coming to the installation. Now, this kind of a network system is not permitted to be used inside the consumer premises. Why? Because if there is a breakage of this PEN conductor, then in that case, the installation or the equipment which is supplied through a TNC network, in case of earth faults, this will get charged and it will provide a shock hazard to the person who is touching this conductive part and the extraneous conductive parts in the building. So this is not supposed to be used. Somehow there is a misconception and people try to connect the common conductor, the PEN conductor, the neutral, and they use the armor if it is grounded locally, and they try to short this within the installation. It is after the main panel or the meter room, they try to short this in the building premises, and this is not recommended, because when you do this within the installation, it can lead to fire or it can damage the equipment. So what should be done? So in that case, you should ask the distribution company or the customer's electrical consultant or the contractor to bifurcate the neutral and earth with the right sizing of the earthing busbar, neutral, and the earthing conductor at the incoming of the building, and then it is distributed as separate neutral and earth. This is the right approach, and this should be done. Now, there are also certain questions which come up, how can we distinguish between the TNC network and the TT network? But before we talk about that, we'll go to the next slide and see what is the TT network. Now, in the case of TT network, there are 4 wires again coming to the installation. So 3 phases, and there's a neutral which is coming from the secondary of the star point of the transformer, secondary. And there is no direct connection between the 2 earthing or the earthings of the installation, the source earthing and the earthing of the installation. They are both independent and they are not connected directly. And this type of a network is called as a TT network. Now, the next type of network is the IT network, where it is same as TT network, except for this difference, where the star point here is connected to the earth using the high impedance. Now, this kind of a system is generally used in the operation theaters in the hospital or the control systems or safety supplies. The reason this is being used is in case of, for example, operation theaters, in case of fault, it should not get disconnected immediately, because if the operation is live, is going on, the patient is on the operation bed. If the power supply goes off, the operation has to be stopped, which could be risky for the life of the patient. So in these cases, the first fault has to be quickly rectified as soon as possible, and therefore this type of a network is specifically used for this application. Now, what is the purpose of earth fault protection? Now, if you don't do this, what will happen is, in case of earth fault, the conductive part of that installation or the equipment is going to get live. And in that case, the person who is touching the body here, if there is an earth fault, and this is the body of the equipment going to the source earthing, if the person touches here, if the MCB or the protective devices that are connected in the circuit are not tripping, then there could be a shock hazard. If the MCB is not further tripping and the amplitude of the current or the magnitude of the current is quite good enough, there could be excessive temperature rise, and that could also lead to fire. So the earth fault protection is helping us to prevent the shocks and also helps us to prevent the fire in case of earth faults. Now, when you talk about the automatic disconnection of power supply, the protective devices are the devices to be used like the NCBs or the RCDs, which will automatically interrupt the power supply in case of earth faults. And for that, the fault loop impedance values have to be according to the table that has been given here. And for each of the impedance or each of the MCBs type that are specified, the type B MCB, type C MCB, or the type D MCB, there are values specified in the code document, and these guidelines have to be followed. The fault loop impedance values have to be taken care in the designing stage itself, and it can be checked on the site when the installations are being commissioned. Now, if the disconnection is not happening, then you can provide a supplementary equipotential bonding. Further, if it is still not tripping, you can help to bring down the earth fault loop impedance values to substantial low values, so that the automatic disconnection of the protective devices is happening. Further, if still does not happen, then you can also use the residual current devices. We will see on the subsequent slide how this can be implemented. Now, we also spoke about two specific points in the IS code, IS 17900 and IS 732, which was talking about automatic disconnection of power supply and protective equipotential bonding. Now, when you talk about protective equipotential bonding here, if you see, this is the main earthing terminal of the building, and the conductive parts like the water pipe, the steel structure in the RCC or the building, the exposed conductive parts of various installations or equipments in the building are connected and brought down and connected to the MET or the main earthing terminal. In case of TN network, this is not connected to the local ground. It goes to the main PE terminal through the MET to the TN network to the secondary of the transformer that is giving the power supply to the building. But in case of TT network, this is connected locally at the building site to the ground. This is how the further elaboration of the protective equipotential bonding is done. In this case, just a moment. So in this case, you see here, the structural steel or the reinforced steel is connected to the main earthing terminal. The metal pipes of the HVAC are connected to the main earthing terminal. The metal pipes of the sewage system or the firefighting system or maybe the water supply system are connected to the main earthing terminal. And at the equipment level, they are also separately connected to this, metal conductors. And in case of fault, how does this help? Now, in case of fault, what happens is you have multiple paths for the current, the fault current to flow, thereby bringing down the fault loop impedance value. And therefore, this helps the automatic disconnection of power supply. This kind of a bonding also helps to bring the potential of all the connected members to one value at which this MET is connected. So basically, ground potential, and since all the equipment or all the conductive parts are at one potential, the chances of a person when he touches this installation conductive part in case of fault and to the other extraneous conducting surface, the shock hazard would not exist. So there are two benefits. One is about the shock hazard and another is about giving a low impedance value, which helps to disconnect the power supply in case of earth faults. Now, these are the values also specified in the code documents, where if the cross-sectional area of the line conductor is less than or equal to 16 square mm, so you can have the same value of or cross-section area of the protective conductor. If it is more than 16 square mm but less than equal to 35 square mm, you can use a earthing conductor of 16 square mm. But if it is more than 35 square mm, you can go take a value of S by 2. Now let us look at the protective devices types. So basically on the left hand side here, you have the MCBs or the NCCBs. MCBs are the miniature circuit breakers and NCCB are the molded case circuit breakers. And how are these identified? You have the type mentioned here. So it is a type C here, and this is the rated MCB value, rated current. In case of MCCB, you have a single trip arm, and you also have the setting points in some cases where you can adjust the values on the side. In case of RCDs, RCDs basically are used for detecting the leakage current, and the value of the leakage current is specified in terms of milliamps. So you'll have this values written down here on the devices. In this case, it is 300 milliamps. You have a test button and you have a single trip arm. Previously, the earth leakage circuit breakers were used, but now the RCDs are used, and generally the RCCB or the ELCB is now called as a RCD. And the protection current values or the leakage current values for which the RCDs are generally available are 10 milliamps, 30 milliamps, 300 milliamps, 500 milliamps, and 1 amp or 1000 milliamps. We also have a device called as RCBO, or residual current device with overcurrent protection, which is actually an integrated MCB and a RCD together. And in this case, if you see here on this side, you have the residual current device, and this side you have the MCB. So this is C25, so type C MCB with a rated current value of 25 amps. You have a test button for the RCD, a single trip arm for the RCD, and a combined trip arm for the MCB. So this is also a combination that can be used, and we'll see what kind of devices are to be used for what kind of earthing network that is available at the building sites. In case of the MCBs, the tripping current values and operating time are also specified in case of type B, type C, and type D. For elevator application, generally we are using the type C, which is having 5 to 10 times the full load current value, and operating time is 0.04 to 5 seconds. And in case of escalators, type D RCDs are used, where you have the tripping current values of 10 to 20 times the full load current, and 0.04 to 3 seconds is operating time. Let us see now what are the types of RCDs or the RCBOs that are available. So if you have a RCD which can only detect AC leakage current, it is called as a type AC RCD. In case of type A RCD, it can detect both the AC current as well as the pulsating DC current. In case of type F, it can detect the AC current, pulsating DC current, and fault currents in the frequency of 50 Hz to 1 kHz. Type B, it can detect the AC current, pulsating DC current, high frequency currents, as well as the smooth DC current or the filtered DC. These are the type B devices which are generally should be used in the application for elevators. So this is also a summary where it is specified here. So type B, if you see, so this green specifies where it can be used, the green cells. So type B has to be used where you have a smooth DC coming out, and there are chances of smooth DC leakage currents on the site and can create a shock. So what is our fault loop? Let us understand that. Now, whenever there is a fault, for example, this is a point at which the fault has happened, and this will be the flow of current through the PE conductor to the star point, goes back through the L1 winding of the transformer and back to the fault point. So this is how the fault loop is available in case of faults. And the impedance value of this fault loop has to be according to the values that were specified in the chart earlier given in the slides, which is also available in the code. In case of TT network, you generally do not have, or I would not say generally, you do not have a direct connection between the two earthing which are here, which is the source earthing and the localized earthing on the site. And therefore, the fault loop impedance test will not pass in case of TT network as well as the IT network here, because there is no direct bonding or metallic connection between these 2 points. Let us see how the automatic disconnection of the power supply will happen in case of TN network. So in case of TN network, whenever there is a fault happening, okay, now if the fault loop impedance value is according to the values that are specified in the chart we have seen earlier, in that case, the MCB will trip. And this is a welcome condition. This is how it has to operate, so that the people who are working on the site, on the equipment, that is maybe either the technician, or if there are end users of the equipment, they are protected. There could be a case that the MCB is not tripping because the fault loop impedance value is not sufficiently low. So in that case, the first option is to reduce the impedance value of the circuit. It is also permissible to have a additional PME or additional earth electrode. And if still the MCB is not tripping, the fault loop impedance value is not sufficiently low, then you have to have, it is a must to have a RCD connected in the circuit so that the equipment does not stay live in case of fault, or it does not also get heated up and there are chances of fire. Now, we have already covered this point here generally, but let me touch upon the RCD requirements here. Now, the RCD should not be used standalone. It should always be used in conjunction or in addition to the MCB. And generally, IS 732 recommends use of 300 milliamps RCD for the protection against fire in the building. And RCDs up to 500 milliamps as a tripping current value are suitable for frequency converters with a 3-phase supply against earth fault. Okay, now there is also misunderstanding in these cases where people think that a 30 milliamp RCD has to be used on the elevators where you have a VFD or the variable frequency drive. Now, if you connect a 300 milliamps RCD on the variable frequency drive, the 30 milliamps RCD is going to trip as and when the elevator starts. It will cause unwanted callbacks on the elevator equipment, and therefore this is not to be used on the elevator with the variable frequency drive. So generally, the values of 300 milliamps or 500 milliamps are used based on the rating of the devices, and a type B RCD has to be used. As we have seen earlier, the type B RCD is the only RCD which is able to detect the AC leakage current, pulsating DC leakage current, high frequency currents, as well as the smooth DC current or the filtered DC current. This is the only RCD, and therefore RCD type B is must. Please do not use any other RCD. RCD A or RCD AC is not to be used here. In case of TT network, as we had seen earlier, there is no direct connection between the source earthing and the earthing which is done at the installation. But according to the code requirements and the protection that is required, the MCB is a must. In addition to that, RCD is a must in the TT network, because since the fault loop impedance is not going to be sufficiently low enough for the MCB to trip, there would be leakages happening, and these leakages will be detected by RCD and the RCD will trip. Again, since we have in the modern day elevators, we have the variable frequency drives connected in the circuit, we should use RCD type B only. Please do not use any other RCDs, RCD A, RCD AC, or RCD type F in the circuits here. Now, verification of automatic disconnection on site. Why this is required? As we said earlier, it is not just enough to have a MCB or a RCD just connected in the circuit. You should have right values of MCBs, ratings of MCBs, right values of RCDs connected based on the rating of the prospective short circuit current, as well as the time that is required to trip the RCD. So before the equipment is handed over to the customer, we should verify that the protective devices are tripping according to the values that are specified for the fault loop current, as well as the minimum disconnection time that is specified in the code. So these are, in the previous chart, you'll see here. So this is a chart that is applicable in case of AC circuits. If it is a TN network, 0.2 seconds is the tripping time. In case of TT network, 0.07 is the tripping time that is required. So the tripping time should not be higher than this. If it is lower, it is welcome, or it should be at least this. Sorry, at the max 0.2 or 0.07. In case of the current values for different type of MCBs, type MCB type B, MCB type C, or MCB type D, based on the rating, for example, if it is a 6 amps MCB type B, then the tripping current value should be more than 45 amps. If it is a type C MCB, the tripping current value when you do the fault loop impedance test on the site, it should be more than 90 amps. And in case of type D, it should be more than 180 amps. If you have a 63 amps MCB, in that case, for type B, it should be more than 473. Type C, it should be more than 661. And type D also, it is more than 661. So when you do this test, this chart should be available with you, and the values should be noted down when you do the test, and the value should be higher than the test values that are given there. So how do you do the fault loop impedance test on site? So basically, in case of MCBs, you have a multifunction tester available, which helps you to do the fault loop impedance test on the site. You have to connect the probes, one on line and the second one on the earth. And there are test buttons available, we'll see on the subsequent slides, to determine the prospective short circuit current that can be flowed in the, earth fault loop that is created when there is a earth fault happening on the particular installation. In case of RCDs, it is required to test using the same multifunction tester the tripping time. Okay. So this is how the multifunction tester will look like. So if it is a TNS network or a TNC network, TNCS network, and with only MCB in the circuit, then you select the high trip current mode, high current trip mode here. If you can see here in the symbol, there is a switch which is shown, which is in the open position. Perform the zero calibration test for the probes. Connect one of the probe on the line and another on the earth on the farthest equipment. In case of elevator installation, press the test button here, and then you'll get the trip current value at this display at the bottom edge. This trip current value has to be more than what we had seen here on this table. Now, when you go to the TNS network or a TNC network, but in addition to MCB, the customer has also provided an RCD. So in that case, you cannot do the test with the high current trip mode. You have to move this knob to the no current trip mode or no trip mode. And on the multifunction tester, again perform the zero calibration for the probes. Connect the probes on the line, earth and neutral in this case on the farthest equipment. In case of elevators, it could be the variable frequency drive, which is providing the power supply to the machine or the motor of the elevator. Press the test button. Again, note down the trip current values here. And this has to be higher than the table which I was showing in the previous slides. If this is higher, then the fault loop test has passed. If it is lower, then the fault loop test current has failed, and you have to work on the measures of bringing down the fault loop impedance values. Now, why this has to be done in the no trip mode? If there is a RCD in the circuit of a TNS or a TNCS network, what happens is if you do this test in the high current trip mode, RCD will first trip and will not allow you to complete the fault loop impedance test. So therefore, this has to be done in the no trip mode so that the RCD does not trip, the NCB trips, and you get the values here. In case of TT network, as I was mentioning earlier, in case of TT network, MCB is a must as well as RCD is a must. And in the case of TT network, it is required to measure the tripping time of the RCD and not the fault loop impedance values or the fault loop impedance current values. So this knob has to be turned into the delta T mode, which is the tripping time mode on the multifunction tester. Perform the zero calibration, connect the probes on the line and the earth terminal, again press this test button and note down the tripping time in milliseconds here. And this tripping time should be according to the minimum disconnection time that is specified in the code. I'll just go back to the slides. So this is the chart we have to refer, which is available in the code. And these are the values which we have to adhere to. One of the misconception about the earthing on the site is, there was an amendment that had happened on IS 14665, and since IS 14665 is still running, it is concurrently running along with 17900. The Part 2, Section 1, Amendment 1 of Class 8447 specifies that there shall be a separate earth pit for lifts. Now, this is somehow a sort of a mistake that has happened in the elevator codes in the past. And if you see on the side, separate earth pit is given, and from this earth pit there are two separate earth conductors which are going to the main switch, the controller, the inverter, and the motor. And unfortunately, in most of the installations, there is no connection which is going from the main earthing terminal to this equipment which is there for the elevator installation. So there is no connection from this MET terminal to the motor or the inverter or the controller or the main switch. So in a way, what is happening is we are converting the elevator installation per se to sort of a TT network. Now, since there is sort of a know-how gap in terms of the network types that are being supplied and the type of devices that are to be used on this network types, nobody is using a RCD in the circuit. And this could be a potential hazard for the people who would be touching the equipment in case of fault. It could also create a fire hazard. It is also, in case of lighting or power supply system faults, there could be dangerous transient voltages that can occur between this isolated earthing system and other parts of the installation. And it could be dangerous for the technicians who are working on the site. So this should not be used. This concept should not be used in case of elevators. The right approach is you connect the two earthing separate earthings from the MET terminal to the equipment, that is a motor, inverter, controller, and the main switch. And from there, you also take it to the other parts in the elevator installation. In case of TN network, this goes back to the secondary of the transformer, from where the star point of the transformer, from where you have got a separate earthing coming to the installation. But in case of TT network, it is a local earth on the site, and this MET terminal is connected to the local earth on the site. So this is the right way to do the earthing on site. Unfortunately, like these pictures are scary, and this is really a cause of worry for all of us. And we might be looking at this kind of pictures day in and day out when we're passing by, but probably we are habituated to this kind of pictures, and we really don't care of what is happening on this. If you see this distribution cabinet or distribution panel has bus bars which are completely open, completely rusted. If somebody touches this, he can get electrocuted. Here there is complete haphazard wire connections, cable connections happening. Again, the bus bars being rusted. Here, a hand twisted wire which is connected. Again, hand twisted wires which are being connected. So this is the kind of quality of wiring that is being done, and the power supply is coming to the building premises. And then we are trying to test the fault of impedance test, which will not happen, it will fail. So it is high time that we are aware of all these requirements and we take care, we talk to the stakeholders, to the power supply companies, and get all these things corrected. These are some of the other pictures which I've seen. The earth is broken on the secondary of the transformer here. So if somebody is thinking on the elevator installation in the building that there is an earth which is coming, maybe only that end of the cable is connected, but there is actually a earthing wire which is broken on the transformer which is supplying to the building installation. The armor of the cable is not connected at all. The same you can see in this picture. And in fact, in this picture, you see the armor is insulated. And if you talk to the distribution company technicians, they say this is how we do it. We don't want to connect it to the panels. And if this is done, there is no earthing coming right from the distribution transformer to this panel. And we might think that there is earthing available to the elevator, but actually it is not. So it will be an open connection. And if there is a local site earthing done, you are actually converting that elevator installation to a TT network. So my sincere urge to all of you here, be aware of all these facts, be aware of the type of network systems that we have in India, and what are the kind of network systems that are coming into the building premises. We need to know this, implement this properly so that the technicians who are working on the elevator and the escalators are safe. The people who are using the elevators, the passengers traveling in the elevators, on the escalators are safe. Our near and dear ones are safe because we also travel into the elevators and escalators day in and day out. We do not want anything to happen to our near and dear ones, and therefore understanding this topic is very, very important. So what are the challenges we are experiencing today? The type of power network received in the building is not known in almost 80 to 85% of the cases, whether it is a TNS network, TNCS network, or a TT network. We don't know. And if you ask the discom companies or the distribution companies, they do not confirm the type of network that is provided on the building. Therefore, it also creates a challenge of what kind of protective devices have to be provided. The next one is the RCDs are not easily available in the market. RCDs are available. The manufacturers like the Siemens, ABBs, Eatons of the world are manufacturing the RCDs, but they are manufactured abroad. You have a lead time of say 4 to 6 weeks or even more than that when somebody is asking for the requirements of the RCDs to be supplied. So this is another challenge we have as far as the Indian market is concerned. The quality of earthing is a major concern, as you have seen in the photographs. Protection, the protective equipotential bonding is also not implemented in almost all the cases, all the residential buildings, except for certain projects where the consultants are available. They are aware of this concept and they're implementing in those projects. In those projects, you will not have any problems, but these are major projects. But in case of residential buildings, which are majority of the buildings, will not have this kind of a concept implemented, and therefore the fault of impedance values are also not to the expected levels, and the protective devices are not working. The concept and the prerequisites of the fault of impedance test are not well understood by all the stakeholders of E&E industry or the elevator and escalator industry. So what is the way forward? Create awareness of the network types and the automatic disconnection in all the stakeholders of E&E industry, the architects, developers, customers, end users, and so on. Representation to the state and the central power ministries through ETD 25 and NFES Representation to the power supply and the discom companies through ETD 25 and NFE. Representation of the state electrical inspectorates for implementing the code requirements for electrical safety, so that all the people who are working on this installation as well as those using this installations are safe. We want our people to come back home safe. And the E&E customers understand and fulfill the IS 732 requirements. This is very important because the E&E industry will talk to its customers, and customers have to talk back to the power supply companies to get the rules implemented. We can influence them to certain extent, but it is all left to the hands of the customers also to drive this subject. So that's all from me here. Over to you, Mr. Gupta Kumar.
Thank you very much, Mr. Nitin. It was a very nice presentation. We had, as usual, more than 200 participants. Now, somebody asked the question whether the certificate is available. Now, I will try to explain our certification schemes of NFE. I'm sure you are able to see the screen, which is nothing but the website of NFE. You see, if you go to the website, training and certification, if you click, you will be able to see the Electrical Safety Professional Certification Scheme. So this Electrical Safety Professional Certification Scheme is actually, you can see the contents here, the certificate based on ISO 17024. Electrical NFE certified electrical consultant, we invite electrical consultant, electrical safety verifiers and installers for getting these certificates. There will be the rules and regulations of the certification you can find in these links. If you click, you will be able to find out the how to apply, who is the PRCV. Those information are available in this particular link. Similarly, we have one more certification scheme, which is fault loop impedance FLIT certification. This FLIT, we put the name FLIT just for the sake of making a good name. It is not, the actual engineer is not only going to test the FLIT, fault loop impedance alone, but something more. Now here, this is not covered at the moment under the ISO 17024, or we have no plans to go for accreditation of the scheme at the moment. This is purely trained by NFE and certified by NFE. There are 3 levels, level 1, 2, 3, 4. You can find the cost of application and the details here. The download, from the download, you will be able to get the terms and conditions of this particular training scheme, and then you can also apply online for this particular scheme. So you can also find the publications in About Us. We are developing this in the About Us. All the publications are provided. For example, the NFE guide on electrical safety audits in hospitals. This guide is already available there. The ESPCS scheme documents can be downloaded from here. The FLIT professional certification scheme is also uploaded in this particular link. So we request you, we are making the website more and more user friendly. We request you to go through the website and make use of it. As a result, you'll be able to get more information. So now this is the additional information which I wanted to give. We have a few questions in the Q&A. Probably you are also able to see the Q&A, Mr. Nitin.
Yes, I can see.
Yes, we have the first question, but it's not related to our today's subject. What if shoe guard of lift failed and goes free fall? What are the requirement of test?
I really do not know what the shoe guard is being spoken about here. I'm not sure whether he is talking about Mr. Bhupat Kumar is talking about the guide shoes of the elevator, but this is nothing to do with the electrical requirements.
Okay, yeah. Mr. Kiran Joshi is asking, are the quality of earthing and fault loop impedance related? If yes, how? If not, how fault loop impedance could be improved in spite of all connections at building side are firm?
Yeah, so Mr. Joshi, as you must have seen in the presentation on some of the slides, we mentioned that first you have to do the earth fault loop impedance test. And if the fault loop test is not passing, it means the fault loop impedance value is higher. And you should take measures to bring down the fault loop impedance values. And the right approach is to start right from the designing stage and not at the implementation stage. And if you are not able to do that, you can do the supplementary equipotential bonding. And if further the fault loop test is still not passing, then you should implement the RCD. Because if the fault loop impedance test does not pass, the MCB is not going to trip in case of fault, and the body of the installation or the conductive part of the installation is going to be charged, giving a rise to dangerous voltages, which can be a potential shock hazard. So to prevent that, the RCD should be implemented so that it can trip and prevent or protect the users or the technicians who are working on the site from the potential shock hazard. It will also prevent the installation from the fire.
Yeah, thank you, thank you. Again, one more question from Mr. Kiran Joshi. Actually, Mr. Kiran Joshi has posted few questions. Few more questions are there. It would be great if Mr. Kiran Joshi can come forward for a discussion so that instead of asking the question, you can also introduce yourself to the audience and we can have a chat. So we go to the question of Mr. Imran Maulavi. So that this means Mr. Kiran Joshi, please raise your hand. We will quickly finish the questions and we will take you directly on the platform so that you can also directly ask the questions. Now we have a question from Mr. Imran Maulavi. Do we need a type C MCB for elevators as we are using VFD and type B is correct selection? Basically, yeah, please.
Yeah, I already answered this in one of my slides. So type C is the right selection. With the type B, there are chances of nuisance trippings happening on the MCB. So the type C is the right one.
Okay, so thank you. Then there is Mr. Bhupat Kumar is again asking, what is the life of a good lift?
Okay, so this is also not related to the session topic here today, but generally the lifespan of the elevator is 20 years.
Yeah.
It goes beyond that, which is designed for much more than the 20 years. But it also depends upon the maintenance, the quality of maintenance, and the know of the people who are maintaining the elevators.
Yeah. So now Mr. Saifullah is asking, is it required for an occupant to obtain ISO certification for lift, or is it's the OEM?
There is nothing called as ISO certification for the equipment or the elevator as on today. It is about the OEM. So it is about the ISO certification of the elevator organization.
Okay, thank you, thank you. So Mr. Kiran Patne is asking, we are using HLF 490S make Hager ELMCB, BTH 480E make Hager ELMCB for lift. Please share your opinion on the same. I think these model numbers, we don't know what these model numbers, hopefully. Mr. Kiran, if you can explain this much more, we will be able to. What do you mean by 490? Yes, is it what kind of MCB is it? Is it a type B, type C, or type D MCB? And what kind of RCD is inbuilt on it? I hope ELMCB is RCBO he is referring to. Am I correct? Mr. Nitin, any idea what is this?
No, I am not aware of this HLF 490S and 480E, BTH 480E.
Okay. I would like to take you to an interesting question. Many elevator vendors ask for 0 volt between PE and N. What is your opinion?
Actually, when you talk about this voltage value here, this is not it's not a practical approach. But generally, voltage of around P and N is around 0.3 volts or so. It is ideal condition that is expected. But given the type of or the quality of earthing that is available on the site, generally in the residential buildings, you will have challenges in these cases. But in case of projects, you will not face these challenges.
Okay, thank you, thank you.
So there are some online, Bhushan, people have raised a hand, so they come online. Bhushan wants to talk to the speaker. Bhushan, if you're there, can you unmute and talk? I've allowed you to talk.
Yes, I can.
Yeah, go ahead, Bhushan.
Firstly, Nitin sir, thank you for the wonderful presentation. It was quite elaborative, and I belong to Electrical Inspector Wing of Maharashtra. So the points that you highlighted were much close to my way of working or my scope of working. So I was very happy to see that. Firstly, the point you highlighted of 14665, that was a very crucial point, and it is a much debated point. So clarification on that point is very essential for both the sides, for the electrical inspector wing to speak about, and for even the consultants to understand that there has to be grid connection for of the lift earth pits that you talk of, that they are earth pits for lifts specifically, and the other earth pits that have been provided in the installation. So that was a vital point that you have elaborated, and thank you for that. Okay. Sir, another the thing that I want to ask is, when we do grid connection of these earthing, in TN connection, TN type of electrical network, the earth terminal should be properly connected to these earth pits. That is what is meant by your explanation, is it?
See, when we talk about the TNS network, in these cases, they're not expecting a local earth pit there. So if you remember the slide, maybe I can post the slide, share my screen again.
I have
Can you see my slide?
Yes, please. Yes, please. Sorry.
Yes, sir.
Yeah. So I'll just go back. So maybe I can take this automatic disconnection, the protective quotient bonding here. So if you see, I was explaining on the slides here, there is a MET terminal, the main earthing terminal of the building, and it is expected in case of TN network, this is going back to the source earthing and not to the local earthing which is given on the site. And in case of TT network, it is expected to be connected to the TT network. So in case of TN network, when you have this, we'll have the MET somewhere here.
Yes.
Use this point. All the earthing conductors in the building installation have to be coming from each of this installation to this MET. From the MET, they should get connected directly to the source earth. And this is a metallic earth conductor which is available between the secondary of the transformer, the star point, and the MET terminal. And this helps you to have the low value of the earth fault loop impedance. This is also probably Mr. Kiran Joshi was trying to ask. And if this value, this earthing is not properly connected, then the fault loop impedance test is not going to pass, because the fault loop impedance values are going to be higher than that is expected.
So,
but in case
sir,
of TT,
sorry, go ahead. Please, sorry, sir. You go ahead.
Yeah, but in case of TT network, you have this local earthing, so you do not have any source earthing coming to the site. So in this case, you have this to be connected, and from here, from this MET terminal, you can connect it to the entire building equipments. Yeah.
Sir. So as you are saying, from the transformer side to the final installation that we are talking of, where the lift and all other installations are connected, there has to be a metallic path, right, sir?
Yes, yes.
So it how can we depend on the cable armor for it?
This is a good question. Cable
answer.
armor, yes, yes.
You see, in several countries, cable armoring is allowed because the way of installing cables are, they do it as per the requirement of the standard. Whereas here, what we see is the armoring or connecting the armor is to the earth busbar of the panels are very complicated. In a lot of cases, these connections are not made properly. As a result, the
Yes,
standard don't recommend to use the armoring. Instead, you use a 5-wire cable.
got that.
Yeah.
Sir, just to elaborate this point, as you rightly said, there has to be a metallic path which is coming from the transformer to the installation. Sir, ideally, when I had joined PWD way down in 1998, we had a specific inspection of World Bank projects in where such installations were are on, normally there. In that installations, we used to have a 8 SWG copper wire coming along with the cable, armor cable that is coming, and that was straight away connected to the transformer side earthing. And on the other side of the installation, it was properly fixed to the MET that has been provided, or maybe the body of the panel which distributes the supply in the LT level. So this was actually forming the written path that we are talking of, if I am not wrong. Am I right or wrong, sir?
Yes.
So somehow, sir, this method, which is actually mentioned in IS 732 also, is actually missed out somewhere in between. Not all the installations are having this provision. So we are actually missing out the provisions that you have mentioned in the diagram. So this if this gets implemented in each of the installation, new or old, we are sorted with the problem, sir. Isn't it?
So, yeah. So, as you said, it is getting implemented in the new and old installations. This is going to be really a challenge. And this is what I was
Yes.
talking about in my slides as well, the second last slide.
Sir, challenges of mindset. Challenges of mindset.
It's
If
the
I
challenge
accept
of,
everything which is given in IS 732 and I dedicate to implement, there is no challenge.
yes. So it is a
It is only
challenge
the
of
decision
know-how.
making by the management and the implementers. Once that decision made, equipotential bonding is not a difficult task.
It's not a difficult. So challenge of know-how, challenge of skill, challenge of will.
Yeah.
Okay. All three have to be overcome, and it will not happen immediately. It is a gradual process. And therefore, we are making this efforts to have this webinars, slides made so that people know what is required, what is the code requirement, and then we have to start implementing this. Talk to all the stakeholders, right from your architects, developers, customers, end users, your power supply companies, the ministries, electrical inspectorates, and so on, so that all come on one board and this becomes a movement. It is a revolution.
True. I am through with first question, sir. Now my second question.
Yeah.
It is about MRL lifts.
Yeah.
For MRL lifts, we have a control panel which is generally fixed at the topmost floor. And there are electronic circuitry. So what I want clarification from you is, where should I place the RCD, or whether it is placed in that control panel always to protect the passengers in the lift car, As we discussed, it should be a type B RCD.
Yeah.
Am I right, sir?
So, yeah. So to answer this question, if you see, when we talk about the MR installations or the machine room installations, you have a main switch location which is available just besides the main machine room main door entry, right? Where you place all the protective devices. for giving the power supply to the elevator installation. Similarly, in
Mm.
case of machine room less, on the top floor, you can have the devices in the small DB box from where the power supply to the elevator installation can be taken. So you can house the MCB as well as the RCD in this small distribution box on the top floor. Or you can place this in the meter room, but in case this protective devices are tripping and you are on a very high-rise installation, then you have to
Yes,
go down,
voltage drop issue.
reset the protective devices, come back again and work. So ideally, the location which is best fitted for the elevator application is to have it beside the controller on the top floor.
Okay. Okay,
Thank
sir.
you.
Got that.
Thank you, Mr. Bhushan. We have a few more
Thank you.
questions. I would like to pick up a few of the questions and ask one
Thank you,
question.
Nitin sir. Yeah, thank you.
Yeah, you're welcome.
Yeah, Mr. Jitin, there is a Nitin, there is a question from Mr. Gopal Prajapati. He is our a very good follower of all programs of NFE and very good supporter of NFE. He is working with the Electrical Inspectorate of Gujarat State. The question is the 30 milliampere RCD in single phase lighting circuit of the lift car. Is it in line with the safety requirement? Probably if you can explain about the requirement of this fault protection and additional protection would be great in this case.
Yeah. So like right now we are talking about this single phase circuitry. So first let me answer this. So as far as the single phase circuit is concerned, the 30 milliamps RCD is the right device to be installed for the to prevent the shock hazards in the single phase. And like if I remember, around a couple of years back, there was a electrocution that had happened in the elevator car, where one of the couple died. It was a fatal accident. Both of them expired in the elevator car because they got electrocuted due to the single phase circuit. So after that, the RCD has been made mandatory by the Gujarat government. PWD is asking for this, and this is the right approach. Many companies are providing this RCDs in the single phase circuitry, but some of them are still not doing that. I think it is high time that it is done for the single phase circuitry immediately. In case of, like Mr. Gopakumar was requesting when we spoke about the fault protection here, as we said earlier, the first approach is to do the fault loop impedance test and have the MCB tripping. So this is the first level of protection. But in case the fault loop impedance test is not passing, the MCB is not going to trip. I'm referring to the three-phase circuit now. The MCB is not going to trip. And if the MCB does not trip, the conductive parts of that installation are still going to remain live. They will be charged. And if somebody touches this, it could be a shock hazard, or if it remains live for sustainable period, then there is a chance of fire hazard. So the fallback protection or additional protection in this case becomes the RCD to be implemented because the fault loop impedance values are higher. So the RCD type B implemented here in case of three-phase circuits, if there is a variable frequency drive, will protect both the shock hazard as well as the fire hazard.
Okay, so basically we should look at two subjects. One is protecting the people in the lift car where light and other single phase electrical 230-volt electrical equipment are used. For that part, a 30 milliampere RCD for that circuit, which is actually a part of the machine. If we think lift as a machine, this is a part of the lift. Am I correct?
Yes.
This 30 milliampere, it's a part of the lift. So it has to be inbuilt in the lift, inside the lift by the lift manufacturer. Whereas once when we connect the entire lift in a building, the entire circuitry which is supplying power to the lift should have basic protection and fault protection. That means in case of any fault, earth fault on the lift, there should be some mechanism to automatically disconnect. And for that, we do the fault loop impedance test or use 30 milliampere RCD type B since VFDs are there in the installation. We have an interesting question from Mr. Amritlal. What is the allowed leakage current in lift motor per kilowatt?
what is the allowed leakage current in lift
Yes,
motors per kilowatt?
leakage current in the lift motor per kilowatt. Probably I would say instead of he asked the question lift motor, I would say lift maybe the entire system, the entire electrical system of lift, including the VFD.
I would not be able to answer it in terms of motor per kilowatt or the equipment per kilowatt, but generally with the variable frequency drives in the circuit and depending upon the rating, we have 300 milliamps or 500 milliamps connected in the RCDs connected in the circuit.
Okay, thank you. I have allowed Mr. Duraiswamy to talk. Mr. Duraiswamy, also Mr. Ramaswamy Venkataraman. If you, Venkatajalam, if you have any questions, you can unmute yourself and ask the question. Mr. Duraiswamy?
Yeah, sir, am I audible, sir?
Yes.
Yes.
Yeah, thank you very much for NFE and Nitin ji. Excellent presentation. My question is in connection with the previous one. You said no 230 voltage for the lighting and other fan applications in the inside the lift. If you are in that case, no, the 230 voltage is derived from 440 to 230 or neutral to 230.
It is neutral.
What is-
It is neutral to 230. So it is a live and the neutral conductor.
Okay, sir. Okay. In case of if they were using a step down transformer for 230 application in many machineries in industry, in that case, if you want RCD, then the secondary of the isolation transformer, no step down transformer to be earthed. Am I right?
Yeah.
It should not be an IT network. Secondary of
So
the
it should not be an IT network as far as the elevator application is concerned.
No. There for certain machineries where after the secondary side of the machinery, secondary side of the isolation transformer is used only inside the machinery. Electrical separation for one machine, electrical separation is a reliable or recognized safety measure. I will just share you and show you where this is written and how you can read. Just a moment, please. Electrical separation. So basically, electrical separation can be carried out for yeah. I'm just sharing the so my IS732. Just hold on. So I'm showing you IS732 here 4.2.13 protective measure electrical separation. So if you read this particular clause, you see fault protection is provided by simple separation of the protected circuit from other circuits and from earth. So this measure, it is a recognized measure provided you can further search as electrical separation in this particular IS732. There are several conditions to be met if you wanted to use electrical separation as a fault protective measure. So basically, inside the machine, your electrical separation is a recognized measure.
Okay. Okay. Thank you, sir.
In that case, you don't need 30 milliampere RCD. We are not talking 30 milliampere RCD, only electrical separation.
Okay. Thank you. Thank you.
Sorry, Mr. Nitin, to answer that question.
Oh, no problem.
Yeah. So also Mr. Ramaswamy. Yeah.
Ramaswamy.
Yes, please.
Sir, my very nice presentation, sir. Thanks a lot. My basic doubt is lifts are provided with the ARD, automatic rescue device. In case of power failure, it will come into action. So once we are making automatic disconnection, when the ARD comes, I am a bit confused. How we can, both are, in my opinion, both are contradictory. How it is matching? So we need a separation, automatic disconnection. Once disconnected, ARD will come to picture. Then how the protection can be achieved?
Okay. See, in case of ARD application, wherever the ARDs are connected, these are supplied through the battery source.
Yes, sir.
and the voltage that is applied is quite low to the machine. But if there is a fault, definitely the ARD also is not going to work.
Okay, sir, I got it, sir, now. It is only for slow speed application, and other control may not get supply, if I am correct.
Yes.
So only when during normal course of action, when there is some fault, disconnection will happen. When ARD works, the only drive to run the drive only supply will be there, if I am correct.
Yes. Yes.
Okay, sir, now clear, sir. I had a doubt, and
and
now
the drive will be supplied to the batteries, and there is an inverter available in the controller, along with some control circuit that is live to just control the safety circuit and the operation of the motor.
okay, sir. Thank you, sir. Nice presentation, sir. Thank you very much. Thank you.
Thank you very much.
Thank you very
Sir,
much.
sir, this is Bhushan here. Since the question has come for ARD, I have a small question that if there is, apart from the three phases, one phase is missing from the DISCOM side, will ARD work? Because
Yes,
now
they-
lift is not working because three phase are not available for the lift.
Yes. As far as the elevator application is concerned, if any of the phases is also missing, this will be detected and the ARD operation will be kicked in and the elevator will be taken to the next level. So there is no man trap in this case.
Yes.
Okay, sir. Thank you. Thank you.
Thank you, Mr. Bhushan. Now we have the next one more person has raised the hand, Mr. Lakshmi Reddy and Mr. Jay Fadke. Mr. Lakshmi Reddy, you can speak. If there is no question, then we will go to the next question. Mr. Ramesh is asking, will it not raise the potential earth conductor during earth fault if it is directly connected with secondary of transformer? I don't know, maybe this is a part of a bigger question also. I don't, Mr. Ramesh, first of all, the question is not full, it's only partial. Will you like to answer, Mr. Nitin?
Okay, can you just repeat this question, or it is available in the Q&A section, right?
Actually, near to my office, somebody is working outside and they are knocking some steel. So there is some nuisance, sound. Sorry for that. The question is, will it not raise the potential of earth conductor during earth fault if it is directly connected with the secondary of the transformer? So I think the first part of the question is missing. Will it not has to be explained? Let us take the another question. You would like to, you can also see on the screen some questions. Would you like to take some of the answers, some of the questions?
Okay, so where are you right now?
The answered questions are already removed from the question. Now unanswered questions are only.
So should I start from the top?
Yeah.
So Mr. Kiran Joshi was asking how the source earthing proves to be better than the local earthing, how the risk is increased with only local earthing is provided. It is not that the local proper earthing does not provide enough protection. So as we had mentioned earlier, as far as the elevator installation is concerned, people still have some misconception, and only the elevator installation is separately earthed. And I was explaining in one of the slides that if you only connect this as a separate earthing to the elevator installation, you're in a way making this installation only as a TT network for the elevator application, and that then it becomes RCD to be mandatory. Secondary, in case of power, earth faults or the faults on the power supply side, and in case of lightning, there could be dangerous voltages that could be available on the devices or the installation, elevator installation, which could be unsafe for the people working on the site. Okay, then the second question is RCD type B used for TT network. Does it lead to nuisance tripping? Will it not lead to dissatisfaction of the customers? RCD type B for the TT network is mandatory, provided you know like what is the rating of the equipment, and the RCD type B rating is also defined according to the rating of the equipment. So you could have a 300 milliamps or a 500 milliamps based on the type of the type of the rating you have for the elevator equipment. The main challenge that is coming for the elevator industry people is that the RCD type B is not readily available in the market, and the requirement is not known to the customer, and therefore they get dissatisfied. And many a times the question that is asked by the customers is why only XYZ company is asking for this RCD type B and your competition is not asking for that. So this puts the technicians on the site into a bit of an embarrassing situation because the people don't understand the topic. Okay.
Yes, this is, the company who is asking RCD becomes notorious. We have
Yeah.
two more participants who has raised the hand, Mr. Kiran Pante and Mr. S. Ramesh. I have permitted both speaking permissions. One of you can start, Mr. Ramesh or Mr. Kiran Pante.
Yeah, myself, Mr. Kiran Patne. Good morning, all of you. So I'm asking same question again. We have separate earthing for transformer as well as lift, and for lift we have connected RCD also. So,
Mr. Kiran, if you can introduce yourself and ask the question, that would be better.
yeah, myself, Kiran. I'm working with Raymond as a project manager, and I'm an electrical engineer basically. So I'm taking care of one high-rise building, maintenance of high-rise building. So we have around 1,500 kVA transformer for a high-rise building, and we have separate earthing for lift as well as transformer also. So, sir, as you said, we need to connect both earthing. We need to connect both earthing, means the star connection and lift earthing also. So how it's helpful? I have connected RCD also for lift. So how it's helpful, and what is the disadvantage?
So if I understand your question right, you have a secondary of the transformer for your project, which is connected to the earth, and you have a separate earth pit for the elevator as well, right?
Yes.
And then you are asking that these two are also interconnected.
Yeah, I have not interconnected, but right now I have not interconnected.
Okay. But then you have not given the earthing from the star point of the distribution transformer to the elevators, but it is separate earthing pit which is connected to the elevator.
Yes.
And then you have provided RCD. So as we were mentioning earlier, in case of lightning, or in case of fault on the power supply side, there could be dangerous voltages that could be available onto the equipment, elevator equipment, which could be a safety hazard for the technicians working on the site, and therefore it is not recommended. It is recommended to have the separate earthings from the elevator system, or rather the secondary of the transformer to the MET of the building. From the MET, you take it directly to the elevator main switch, from where it can be distributed to the controller, inverter, machine, and so on.
Okay.
I hope it is a TMS network on the side.
Yes. Yeah.
Okay. I'm just sharing one of these.
Thank you, sir.
Mr. Kiran, I am sharing one of the standard which is becoming an Indian standard very soon. So this concept of this separate, this independent, neutral separate, body separate, and all those things, basically, in fact, regulatory code prohibit this device in some countries. For example, in Indian standard, it will be written as this is prohibited. That means the method which is followed, let us say the general practice of earthing which we carry out in India, this is a mistake. It's wrong. It is like a transformer, neutral separate, body separate. This is what we are fighting against. This concept is, we don't know from where it started, as Mr. Bhushan told, during 1990s. So there was a copper wire running back to the neutral of the transformer. That is the correct system. But nowadays we are going more and more wrong things. So you have to make a proper network, like a established network, like a TNS. Thank you.
Yeah, thanks.
Just to add, like Mr. Bhushan was also talking about this conductor, and Gopakar answered that there is a 5-wire cable or 5-conductor cable which is being used, and there is a dedicated earth conductor. But unfortunately, this practice has also stopped, and the cables are with 4 wires, and you have a armor coming. But the armor is unfortunately not connected, which is again putting us into a problem.
Yes, the best way is to use 5-core cable for a circuit with a 3-phase neutral plus a P conductor, protective earth conductor. We have Mr. S. Ramesh who has raised the hand. Mr. Ramesh, you can unmute or you can speak.
Am I audible? Good afternoon, gentlemen. This is Ramesh from Chennai. Am I audible?
Yes.
Yes. So this is Ramesh from Chennai. I'm working as a general manager for Prestige Group, managing high-rise buildings in Chennai and Hyderabad, basically an electrical engineer. This question was raised. Wonderful presentation. It give a lot of insight for lift and lift safety, electrical safety, all these things. Really enjoyed and learned so many new things. My point is, during our discussion, one person told normally we used to run a 8 SWG wire along with the cable to connect between transformer secondary neutral and to the load. So during fault condition, during fault condition, huge fault current will return through this 8 SWG. Definitely that will raise the potential of the 8 SWG copper or GA wire. That is why normally this earth conductor is not allowed directly to connect with transformer secondary. So is it allowed, is it advisable to connect directly secondary neutral to the earth of the equipment?
May I answer this?
Yes.
Yeah, Mr. Ramesh, whatever, whoever explained this to you, he is wrong. First of all, 8 SWG wire is not the standard size. You have to size this wire based on the size of the phase conductor. There are certain rules. So based on the size of the conductor, for example, up to 16 square millimeters, same size. 25, 35, 16 square millimeters. More than 35, half the size of the phase conductor should be the minimum size of this earth fault current return path. During an earth fault, enormous amount of current flows through this particular conductor, and the conductor has to be sized to handle that particular current without any temperature rise. So these sizings are already there in the standard. It must be, if you are going for a TNS system, this earth conductor must be connected to the neutral of the transformer. Now, if you have your own transformer and your own DG set, you must follow TNS system or TNCS system. But basically, both are the same. TNS, there is a metallic fault return path. Now, once when there is an enormous amount of fault current flow, there can be the potential buildup in the conductor, and that we have to handle by the way of equipotential bonding within the building. What you can do is, if you hold on, I will just show you a picture from the NEC, I will show you where this is explained in the book. So you can go through the book, and this is our National Electrical Code of India, NEC. I am taking you to page number, yeah, exactly. This is the page which I wanted to explain. Just a moment. You look at this figure. The first one, illustration of earthing and protective conductors. This is how you should make the protective equipotential bonding. And now if you look at the second one, you see at the left side, you can see the main equipotential bonding, and then you have the secondary equipotential bonding, the earth fault, the IF is the fault current going through the PE conductor, ZPE. Then the requirements are, you see, supplementary equipotential bonding to reduce touch voltage less than 50 volt. This is what is required. So basically, you need this connection at multiple places. I would recommend you go through this. This is in page number 275 of NEC. You look at those page numbers, you will be able to get the answer. Thank you very much. I hope it's
Got the
clear.
point. Thank you.
Thank you.
Gopal sir, I want to clarify my point, what I said. Am I allowed?
Yes, please.
Yeah. Sir, basically what he said that I have to connect the 8 SWG bare wire to the neutral. That was wrong. I was not saying that it will be connected to the neutral. It will be connected to the extraneous part of the transformer or DG set. Means it will be a body connection right from the transformer side, that earthing grid that has been done to the MET of the location of the LT. And the method was having two separate and distinct 8 SWG GI wires, 8 SWG or a lower size, and a GI strip along with it. That was the standard method if you are talking of from the transformer or DG side to the LT distribution. So this was an additional provision along with the armoring and even a GI strip that is connected from the body of the earthing or the grid of the LV side to the installation distribution location.
You see,
So it was not connected to the neutral. That was something wrong that he said. It was not connected to neutral.
But finally, this whole interconnected metallic parts has to be connected to the neutral of the source as well. It has to be. What you can do is, Mr. Ramesh, for more information, you can go to IS 3043 2018, look at figure 38 and 39, then you will get more information.
Sure, sir.
So, any other question? Yes, Mr. Nitin.
Yeah, just to answer what Mr. Bhushan was also saying, even if you connect this two separate conductors of the GI strip that is coming to the transformer body, invariably what will happen on the transformer, the secondary side, the neutral and the earth point in the transformer would be grounded. They'll be connected to the body of the transformer anyways. So this is going to be a connection there.
Yes.
But it would be better that the strips are connected to the right point, to the arc point or the star point of the transformer directly, and then the transformer body is on.
Yes, and I understood the point Gopal sir was saying. The size of this conductor which is getting connected between the two locations matters, because that is as per the calculation of the percentage impedance that we do. I got that. That point is very well taken. That is the correct point.
Thank you, Mr. Bhushan. We have Apau sir.
Yes, sir. Good morning. Good morning, sir. I'm audible?
Yes.
Yes.
Yeah. Thank you. Thank you. Thank you, Mr. Nitin. It's a wonderful presentation. And most of the questions I hope, have been answered to the satisfaction of our participants. Hope doubt will always be there. We can get it rectified by a continuous, by continuously raising the questions. It's one part, it's good. But I would like to supplement to the presenters and some of my views. For example, there is always a question whether we have to connect the neutral of transformer with the frame. This is a ever persisting question in all our webinars. Still, people are not satisfied, but we can't always make the people compulsory to connect it. We have to satisfy. Unless we satisfy their mindset, the continuously followed practice over a decade, several decades, could not come to one. For example, the interconnection of earth electrodes is statutory as per regulation 43(6). It is existing for the past several decades. Also, regulation 18 insists the interconnection. That is, consumers' protective earth terminal should be connected to the earth neutral of the supplier at the supply point. So this is existing since 1937, even before the birth of Indian electricity rules, 1950. We are celebrating 100th year. So this is the only thing which is yet to be resolved in our country. In our country only, I can say. Because it affects the whole system. It is not affecting the LV installation also. It is affecting the whole system, the entire protection of the distribution network and the suppliers network. Everything as a grid is not interconnected because of this missing link. But there is another challenging situation. The situation is we have to connect. If we connect, I think you better refer class 7.5.2.2 of IS 732, where it is clearly mentioned what could be the temporary overvoltage if the consumer make a TT connection or a TNS connection when the distribution transformer is connected, interconnected. That means the body is connected to the neutral or it is separated. So it all depends upon the connection of distribution transformer. In case of consumer's own transformer, no issue. It is the consumer has a control over it, but they can't have a control over the distribution transformer. So that's why people, in the absence of any right of way, they can't have a presumption that we have to connect or not. So finally, we have a beautiful tool, earth slope impedance. If the earth slope impedance exceeds, you have a RCD. But unfortunately, RCD responds for the downstream. Okay, sir. RCD responds for the leakage within the consumer premises. It will not respond for the temporary over voltage injected from the supplier's distribution transformer in the case of a fault from ST to, that is from the ST side of transformer, say in the line, something else from ST to earth. So in such cases, you must achieve the equipotential bonding. There is no other way. But unfortunately, it's not happening. We have to work towards it. The regulation 18 have to be implemented, and regulation 43.6 have to be implemented, and the separation and interconnection has to be clearly understood by the consumer. Unless they understood, they can't be convinced you connect it or you omit it. So in a nutshell, I can say, if you want to protect your equipment and your people, RCD, there's no problem. If you want to protect your equipment from over voltage, because lifts and hospital installations are more stringent. They require more stringent requirement because of people safety is involved. They are in a closed vehicle, and hospital there are weaker people. There you can't have a clinic with anticipating temporary over. In home also, there can be some compromise. We can't always be touching the random event of temporary voltage is minimum. That I do not recommend, but even then it is possible that there are no fatalities, and there are certain fatalities too at the earth roads provided outside the premises. If somebody touches or animal touches, it will become fatal. So it can be easily felt that a temporary over voltage is likely to be introduced at your consumer equipment and your earthed conductors during the ST to earth fault. The only remedy is to have an equipotential bonding along with a TNS connection. These two things, we have a long way to achieve it. This is my opinion. It's not so easy. The entire country and distribution companies have to be sensitive, not only the consumer. Unless they are sensitized, the 100-year-long dispute can't be resolved. Not dispute, hazard can't be resolved. That's my opinion, sir. So I request members to please go through 7.5.2.2. We have presentation in our NFE website on temporary over voltage and its effect on consumer premises. Please go through. Thank you, sir.
Thank you, sir. Thanks for all your inputs. As you said, it is really a very, very long way to go, because if you the situation in the metros is to a certain limit acceptable, but if you go to the outskirts across India, the situation is really not to the acceptable level, and there are a lot of hazards that are available. I've shown some of the photographs. I will not name the city here in this larger forum, but this is how the situation is across India in all the states you go.
1 second, sir. Sorry, I have wrongly told the class. The relevant class is not 7. The 7.5.2.2 is related to the Amrit question. What should be the body to earth current? There is a table in the IS 732 under 7.5.2.2. So regarding temporary voltage, the correct class is 4.5.2.2 and 4.5.2.2.2. So sorry, I have wrongly informed the. I confused with the Amrit question. Amrit Lal asked one question: what should be the current between the permanently connected equipment and the earth current? See, leakage current. That is can be referred from class 7.5.2.2. Regarding the temporary voltage, please refer 4.5.2.2 of IS 732. Thank you. Thank you. Sorry for the misleading information. Thank you, sir.
Thank you, sir. Thank you. Thanks, Apav, sir. So probably it's time to close the program. We have still some more questions. I would like to take the last question. This is the final, the last question, which is from Mr. Dr. Mahendra Chiliguri, our very serious member from NFE. The question is, every lift should have insulation mat inside the lift for passenger safety. What is your view on that, Mr. Nitin?
Insulation mat inside the lift for the passenger safety. See, invariably, if you see, even if you put the insulation mat inside the elevator on the floor, you have the wall panels or the car panels, which can be conductive, and that could still give you a shock if you're connecting one hand to the panel and one hand to maybe extraneous or any other conductive part in the building. So this is not really going to benefit.
Yeah, putting the mat is not going to, it's not going to benefit the customer because the lift as a whole is metallic. So touch voltage simultaneously, it's all metallic parts can be touched. In fact, if the whole lift car is metal, and if there is a fault, of course, the person inside the lift car is not supposed to get a shock because he is already at 230 volt. The problem will happen only when he steps into the lift from outside. So probably it's time to close the session. Will it be okay, Mr. Nitin, if we can close the session?
Yes, yes.
Okay,
Thank you so much.
Thanks, Mr. Nitin, for a wonderful presentation. This is our second program, and in fact, all the programs we have extremely good audience. I think the first one we had more than or close to about 500 participants. So thank you very much again. Probably we can come back again with another subject of lift probably in another day, because there were questions regarding ARD and other things. Probably if Schindler have any other experts mechanical parts, we can have a webinar as well.
So maybe I'll appreciate if all these questions are sent back to us or me, so that if there is a session required to answer all these questions, we can definitely do that.
Sure. Sure, that's good. We will send to you, and if you can also prepare the appropriate answers, we can put it in our website on the blog so that it's accessible to everybody. So thanks all the participants. Thanks Apav sir, and thanks Mr. Bhushan for the interactive, for making the session interactive, and all the participants for their active participation in the program. We still have a few more questions to be answered, but due to time, we are unable to answer the question. The presentation as general, we will not be circulating the PPTs. Also, we will not be providing any certificates of participation. Instead, there is a much better method. The videos of the program will be uploaded in our YouTube channel. You go to our YouTube channel, look at the website. There is a link to the YouTube channel. You can look all the videos of our webinars in the YouTube channel. This is point number one. Point number two, for certification, these informative sessions are not useful. You have to write an examination, a small test and examination, and demonstrate your skills, and you can get the certificate. There are 2 schemes running on. Please go to our website and have a look, and you can start applying for NFE certified FLIT professional or NFE certified electrical designer, verifier, installer. All these schemes are open now. With this, we would like to close the session. Thanks once again to everybody for the active participation of the program. To Mr. Nitin, if you have any message, you can pass on.
So thank you all. Thanks for participation from all the members who have joined this session today. And as I said earlier, our near and dear ones could be, involved in some of the, like when they are traveling in the elevator or the escalator. So it is necessary that we sensitize all the stakeholders and ensure that all our technicians, near and dear ones, and the customers are safe. Let us make this as a movement, as a revolution. Thank you so much.
Thank you. Thank you. Let's make Bharat electrically safe. Lakshmi, it's time to close the session. Thank you very much. Thanks to all.
Thank you.